statement P is given as x is an irrational number, statement Q is given as y is a transcendental number, R is given as x is a rational number if and only if y is a transcendental number. So, statement 1, R is equivalent to either Q or P. So, now we will try to write this statement. Now, first we will see what is R. So, we will try to write the statement R. Now, statement R is, now look at this carefully, x is a rational number. Now, x is an irrational number is P. So, x is a rational number should be negation of this. So, this is, okay, I will write it here, this is negation of P if and only if y is a transcendental number. Now, y is a transcendental number is given as Q. That means from here we will get R. So, R is nothing but negation of P if and only if Q. Okay, now go to statement 1. So, now let us look at statement 1. Now, R is equivalent to, now we will substitute R. R means it is this now. So, negation of P if and only if Q. Okay, they are in statement 1 they are saying, is this equivalent to either Q or P, that is Q or P, either Q or P, you can write it as Q or P. So, now you have to say whether this statement is correct. Now, there is similarly statement 2. Again R is equivalent to, R means the same thing, that means negation of P if and only if Q is it equivalent to negation of P if and only if negation Q. Now, these two statements, the validity of these two statements should be checked. Okay, now actually if you see this carefully, this can be just written as P if and only if Q, because there is a law like this, negation of P if and only if Q is same as P if and only if negation of Q. So, there is a law. So, this is same as this. So, according to this negation of P if and only if negation Q, now you see what happens when you do the negation of if and only if. The first statement is written as it is, the second statement gets negated. Therefore, this is actually, this is equivalent to, the first statement will be as it is if and only if, the second statement gets negated. So, negation Q gets negated, so it will become Q. Yeah, now this why I simplified this to this is just to make the work simple. Okay, now what we will do is we will write the truth table for all these things. Okay, now I will just draw the truth table here. So, first I will take P, then I will take Q, then I will take negation of P, then okay, so negation of P. So, I will substitute this here. Now, P I will take TT FF. Here I will take TF TF. Now, negation of P. Negation of P is FF TT. Negation of P is negation of this. So, FF TT. Now, I will try to construct this negation P if and only if Q. So, now next I will construct negation of P if and only if Q. So, if I do negation of P if and only if Q, so it is given here. So, therefore, I have to do if and only if of this with this. See, negation of P if and only if Q. So, false if and only if true is false, false if and only if false is true, true if and only if true is true, true if and only if false is false. Therefore, you can see the right hand side of both the statements is this. Okay. Now, Q or P is standard. Now, Q or P or Q is one and the same and it is standard. So, P or Q is nothing but true true, true, F. We know that this is a standard table, OR is a standard table. Similarly, now this is why I have simplified this to this, because P if and only if Q is a standard table. So, if you go for P if and only if Q, now this is T F F T. Yes. Now, if you compare this table, now this is not equal to this, see. So, this table is not equal to this. That means this statement is not equal to this. That means statement 1 is wrong. Now, again if you compare this table with this, again this is also not equal to this. In fact, this table and this table are negation of each other. Where there is F, you find T, T, F, T, F, F, T. So, therefore, this table is not equal to this. That means this statement is not equal to this. That means this is not equal to this also. That means even statement 2 is wrong. That means the answer is statement 1 is wrong, statement 2 is wrong, and option D is the correct answer.